Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adil bin Muhammad Adlan and my magic number is 01DE20F2011. And I'm in class DE5A. Okay, for my teammate is Muhammad Rusdi bin Ahmad Razi. His number matrix is 01DE20F2003 and we're from group 10. Okay, for the today I will explain about the answer of end of chapter 1 for Fundmetal Renewable Energy. Okay. So first question is list three type of installation commonly in use with the turbine. Example for each installation. Okay, firstly is the Francis turbine. It has the circular plate fixed to the rotating perpendicular to its surface and passing through to its center. The water enters the casing under pressure and is guarded through a set of fixed or adjustable slot called guard vents around the casing, which direct the flow of water to the turbine blade at the correct angle. Okay, secondly is the turbo turbine, an improved type water turbine design in which a jet of water strike the turbine's blade. Okay, so next is designed to have a higher specific speed. In the case the jet aim to strike the plane of the runner on one side and exist on the other. Okay, so the lastly type of installation is Pelton turbine. Okay, so the Pelton turbine, also known as a Pelton wheel, and named after its inventor Lester Pelton. It consists of a set specially shaped bucket mount on a periphery of circular disc. It is turned by jets of water which are discharged from one or more nozzle and strike the bucket. Okay, so the second question is one suitable turbine runner according to each installation type. Okay, so the answer is suitable turbine runner according to each installation type is Francis turbine, primarily used for producing electricity. The power output of the electric generator generally range from just a few kilowatt up to 1000 milliwatt. Each stroke mini hydro installation may be lower. The best performance is seen when the head height is between 100 to 300 meter. Okay, for the next question, the second question of the end of chapter is discuss two potentially of hydroelectric power plant in generating grid scale electricity supply and two environmental impact of hydroelectric development by referring to real power plant example that have been previously reported in Malaysia. Okay, for two potential, we have the renewed interest in smaller system appears to be consequence of environmental issues. Okay, next is some of developing countries are seeing advantage in stepwise electrification by the establishment of local radio nation wide grid system. Okay, for the environmental impact of hydroelectric development, the Ulu Jalai hydro project for 372 milliwatt, for which SMEC carried out detailed design. Construction supervision and contract management was commissioned in 2016, comprising an 88 meter high roller compact concrete dam, spillway discharge capacity of 2,300 millisecond, and an underground power station. Okay, the next is the Hulu Terengganu project for 265 milliwatt was some mission in 2050, comprising two cascading schemes. The 75-meter high Puah Edfield Dam, 250 milliwatt with 3 gate spillways and an underground power station. And the 36-meter high Tembet Constrict Dam for 15 milliwatt with area overflow spillway and a surface power station. SMEC carried out the feasibility study and tender design for the project.
Hi, my name is Muhammad Rusdi bin Ahmad Razi. My major number is 01DE20F2003. So, my question is number 3 from the EOC. So, question number 3 is by considering the technical aspect below, demonstrate the principle of hydroelectric in electricity generation with respect to. So, the number 1 is generator frequency and voltage control principle. So, the frequency containment in hydropower plant is automatically controlled by speed governor within second. Disturbance such as fluctuation in the net heat and again may diminish the performance at the controller of the speed governor. So number 2 is generator synchronization using a synchro check relay. The numeral cyclocheck relay type SPAU 140 is a voltage measuring relay designed to use when the power system are to be connected together. The cyclocheck relay SPAU 140 can be used for both between cyclocheck and voltage check. The cyclocheck function is used when the two separate network or two electricity interconnected network section are to be connected. The voltage check of a network, the cyclocheck function allows circuit breaker closing in the voltage on both sides of the circuit breaker fulfill the preset condition as the magnitude, phase and frequency different. Number 3 is generator operation with speed and voltage regulation. Size of voltage can vary by the three factors: the size of the magnetic field, the more flux line, there are more flux line there are for the conductor to cut. The strength of flux is directly proportional of the induced voltage. The active leg of the conductor, active leg meaning the part of the conductor that actually pass through the field. The active leg is directly proportional in the induced voltage. The speed at which the conductor pass through the field. The faster the conductor pass through the field, the greater the voltage induced. The speed is directly proportional to the induced voltage. So the number 4 is generator speed and voltage regulation with drop. The power output of a generator decreases as the line frequency rises while using the drop speed control mode for AC electrical power. It is frequently employed as the governor speed control mode when a prime moving is powering a synchronous generator that is wired into the electrical grid. It operates by modulating the prime mover rate of power production in accordance with the grid frequency. With drop speed control, the prime mover power is adjusted to 100% at minimum operation frequency, 0 when the grid is operating at maximum operating frequency, and intermediate value at other operating frequency. So number 5 and the last one is generator parallel operation and load sharing. So paralleling and load sharing are two concepts that are frequently used synonymously but actually means to two different things. In order to prevent any generator from being overloaded, load sharing is technique for dividing the load or power demand among several generators. Typically, a load sharing controller is used for this, which automatically modifies each generator output depending on demand. On the other hand, paralleling is the process of linking two or more generators to work together as a single unit. By using paralleling switchgear, which enable the generator to be synchronized and run at the same voltage and frequency. This is typically accomplished. Even though they can be combined, load sharing and parallelism are not the same. Overloading can be avoided by using load sharing. So that's all from us. Thank you.